Hi, my name is Nicholas Wagner, and I am the math instructional coach for the Barney Charter School Initiative. We're going to be talking about bar modeling, which is one of the three main Singaporean techniques for modeling problems and for solving problems. Those three that we emphasize are number bonds, place value, and what we're doing today, bar modeling. I want to start off with a more complex problem, just to kind of make an argument for the value of bar modeling. We're going to solve this problem using algebra, and then I'm going to solve it a slightly different way using bar models. Let's read the problem. I have 6 times as many muffins as scones and twice as many muffins as donuts. I have 170 pastries altogether. How many donuts do I have? So the first step that you're going to do is you're going to, using algebra, you're going to set up the variables. Muffins is equal to 6 times the number of scones. Muffins is also equal to 2 times the number of donuts. And you know that muffins plus scones plus donuts is equal to 170. Now, you have to get the equation in terms of one variable. So we're going to put the equation in terms of donuts. If muffins is equal to 6 scones, and muffins is equal to 2 donuts, then we know that 6 scones is equal to 2 donuts by the transitive property of equality. And therefore, scones is the same thing as 2 donuts divided by 6 by division, which can be reduced to donuts divided by 3. So scones is equal to 1/3 donuts. So then we can go back and use substitution to put it back into the equation where we have our total. So we have muffins, which is equal to twice the donuts. So let's go back here. Let's go ahead and rewrite this. Muffins plus scones plus donuts is equal to 170. I'm going to substitute. Muffins is the same thing as 2 times the donuts, plus scones is donuts divided by 3. And then we already have donuts in terms of itself. It's equal to 170. So if you're familiar with math, you have to get a common denominator to add those up. So then I'm going to do that right here. And I have that 6 donuts divided by 3 plus what we already have, donuts divided by 3, which was representing the scones, plus 3 donuts divided by 3, 3 divided by 3 because that's 1, is equal to 170 pastries. And then you see there that 6 plus 1 plus 3 makes 10 donuts divided by 3 is equal to 170. You multiply both sides by 3 to reduce to 1. So you have 10 donuts is equal to 510. And then to solve for donuts alone, you divide by 10 on both sides, and you have that donuts is equal to 51. So you have 51 donuts. This problem is very simple if you follow these steps in algebra, but there's an even simpler way to approach this problem. I'm going to erase the algebra, and I'm going to show you it using a bar model. And the way that I'm going to do this is, the way that I would normally do this when I'm teaching, is I would read the problem all the way through. I would rewrite my question in the form of a sentence. So it says, how many donuts do I have? I would rewrite it as I have blank donuts. By the way, the process that I'm explaining to you right now, I would do frequently with every problem that I have, so that students know kind of a process, a step-by-step structure that they can follow, because some students need to know where to start. They need a place to start. So we read the problem all the way through, then we restate the question in the form of a sentence, and then we go back and chunk it and read through it a piece at a time and stop when I can draw something. I have 6 times as many muffins as scones. So I know I have muffins and I have scones. And if my scones is 1 unit, my muffins is going to be 6 units. Sorry, I'm a bit of a perfectionist. It probably still won't come out perfectly, but so 6 times the number of muffins as scones. Okay, I could draw that and continue. And twice as many muffins as donuts. So I have donuts, and my muffins are twice as many as my donuts, which means I'm going to have how many of these units? I'm going to have 3 of them. If muffins is twice as many, then donuts is half as many of the muffins. So I will have 3 of these units. Notice these are all 3 equal-sized units or bars. And so what I can do with them is before I continue, I'm going to throw on my total. I have not finished reading the problem, so I continue until I finish reading the problem. I have 170 pastries altogether, and now I come to my question, how many donuts do I have? So I'm going to put a line here with a question mark, looking for that final answer. So I'm going to total up the number of units that I have, which I count as 10 of these bars. And 10 of those bars, which are representing the pastries, is equal to 170 in total. So then we should get it down to 1 bar so that we know how much one of these units is worth. So I divide both sides by 10. So that 1 bar is equal to 17. But I'm not quite finished. How many of these units am I looking for? I'm looking for 3 of them because that's the donuts. So then I multiply by 3 on both sides. And I have that 3 of these bars is equal to 51, and I've solved my problem. For many people, this is a much more intuitive process. It's much clearer to students. And I think that it is a very helpful technique. So before we continue and do more problems, I'd like to explain the basic setup of types of bar models. There are 2 types of bar models in terms of their basic form, and that is the part-whole model and the comparison model. So we have part-whole, which some people call the part-whole model, and then we have the comparison model. Okay, the part-whole model looks very similar to what we've seen in terms of a number bond before. We have our whole quantity, and then we have a part here and a part here. Okay. So you can use this largely for problems relating to addition and subtraction. You can have the whole and a part, and you're looking for another part. You can have both parts looking for the whole, and you can continue to make all the different iterations of that. Then we have our comparison model, which is a larger quantity and a smaller quantity. Sometimes there will be multiple quantities here, but I'm giving you the simplest form. And then you have the difference between them. And your total bracket. Okay, so those are the two types of models. I recommend for the remainder of the video that you take a second to write those down in your notes and reference them as we continue to do some of these problems. So we have the part, whole, and the comparison. Okay. Before we start practicing, though, I want to make a few notes. Students may draw different bar models for the same problem. So the same idea applies, that you need to allow for creativity in the problem solving that you're doing in your math class. If a student draws a different bar model, take a minute, if you have a document camera, to take that picture and put it under the document camera and show your class and walk through what was different about their model. Is their model accurate? Does it still work even though it looks different? So there's no one right approach to solving a particular problem necessarily. You can also ask students, what do you like about that model versus the other model, and get them to compare and use explanation, use language to really figure out how to articulate what it is that they like about models and what they like about another model. So let's go ahead and try a problem. Stacy had 2,378 books. She sold 259 of them. At a yard sale, how many did she have left? This would be, you can do it both ways, actually, with a part, whole, or a comparison. And one thing that you'll recognize is that students will come up with the different models on their own, and they'll start to realize that there's certain words maybe that would suggest that they should use a comparison model over a part, whole model, or they might get to the end of drawing one model, not like it, scratch it out, and then switch to the other model. That's okay. Allow them to really find their preference, and they'll start to recognize that it is true that there are certain problems that just lend themselves more naturally to one or the other. So this one I'm going to use a part, whole model on. So I have my total, or I guess I should back up for a second and reiterate what I just did moments ago. You read through the whole problem. Stacy had 2,378 books. She sold 259 of them at a yard sale. How many did she have left? After we do that, remember, we come down to our sentence. We write our sentence. I want to reiterate that this process, following this process, really gives structure to some students in approaching word problems. So my sentence is down here. And how many did she have left? You would write Stacy had blank books left. So we know that going back to, we would start our model again. Stacy had 2,378 books. I can draw that. These are the number of books that she has. And the total is 2,378. And I would keep reading. She sold 259 of them. I would write sold. The quantity would be 259. And you want to know how many did she have left. One important note, I recommend only putting your question mark where the final answer is going to be. You might have a multi-step problem. If you have a multi-step problem, you can throw other question marks in there. But if you do that, I recommend putting the question mark and an F for final, or some note that that's what I'm actually finally trying to end on. Okay, I'm going to go ahead and skip the arithmetic for the sake of the length of the video, but I wanted to show you that this is how you would model this problem, and you would do, you have the whole, you have a part, and you're looking for the other part, so this would be a subtraction problem. Okay, the next problem that we're going to do is going to be a comparison. Jerry has $6 more than Kevin. Kevin has $11. How much money do they have altogether? All right, so I've already read the problem once through with you. I would go next to my sentence. How much money do they have altogether? Jerry and Kevin have blank dollars altogether. So then we're going to go back and break the problem into parts that I can draw. Jerry has $6 more than Kevin. So I have Jerry's amount and Kevin's dollars. So Jerry's dollars and Kevin's dollars. Some people will just start drawing the problem. Some people like to give them equal quantities first and then extend the one that has more. Jerry has $6 more than Kevin. Extend that. The difference here is that $6, right? And Kevin has $11. How much do they have altogether? And that's where I'm going to put my question mark, because I'm looking for the total. So I know that this is $6. This is going to be $11. And what's helpful about drawing them as equal bars is you get to see that those are the same and that the difference here is $6. So you now know that Jerry has $17 and Kevin has $11. So 17 plus 11 is $28. Okay? So this is a comparison. You have a larger quantity, a smaller quantity, a difference, and a total. So you can come back down here and complete your sentence. Another thing I should mention that, and I'll give credit where credit's due, Kevin Mahoney, who has has been doing Singapore math for many years, Dr. Kevin Mahoney, has created this structure where you have the question, you have the answer sentence, and then you have kind of a break between the bar model and the arithmetic. So students really who struggle with knowing where to put things and who might get stuck solving the problem know what the format should look like. It's very helpful for those students. As they continue to grow in their comfort with where to place things, you no longer have to format it for them. They should just know how to start doing it on their own. Let's go ahead and do a few different problems from these. I'd like to show you a variety just so that you have familiarity with these. I'm stealing these from the Dimensions Math 3A Teacher's Guide on page 126, which is Chapter 4, Multiplication and Division, just so you have the notes on where to go to. But I wanted to walk through them with you. There are 3 children. Each child has 8 pencils. Okay. How many pencils do they have in all? I'm going to go ahead and skip the normal walkthrough of the formatting and just go ahead and draw the model for you. There are 3 children. Each child has 8 pencils. I want to note something here. Some students may want to write an 8 underneath each of these. That is okay. That is less abstract, so they may eventually move to where it's more abstract, and they understand that these are all equal quantities. And you're wanting to know how many pencils they have all together. So this is representing pencils. So that's how I would set that problem up. There would be 8 times 3, which is 24 pencils. So they would all have 24 pencils. I mean, they would have all 24 pencils in all. I'm going to change this to a slight variation of the same problem. Mrs. Turner has 24 pencils. She gives each of her 3 students an equal number of pencils. Forgive my shorthand. How many pencils does each student receive? Okay, so we know Mrs. Turner has a quantity of 24 pencils. These are pencils. You know your total, 24. She gives them to 3 students, which means we're going to break this bar into 3 equal quantities. And you're wanting to know how many pencils does each student have. So you are looking for this quantity there. So you would do 24 divided by 3 gives you this one, which is 8. right? So that's a different type of multiplication problem there. Now I want to give you one of the division types of problems. Mrs. Turner has 24 pencils. She gives 3 pencils to each of her students. And you are looking for how many students receive pencils. All right, so you start with this quantity again of 24 pencils. Each student is receiving 3. And you want to know how many 3s fit into 24. So there are a variety of ways to do this. One, the way that the dimensions text has it is that there's a 3 here at the beginning, a 3 here at the end, to show that you don't know how many is going to be in between or how many there are altogether in terms of students. So this is a student. Another way that I've seen this drawn is to do a similar model. And this is actually the model that I prefer. So this is a different picture. Option 2. Let's call this option 1. So you can clearly delineate the two. And use an ellipse here to show that this is going to be continued and you don't know for how long. This is the model that I prefer. However, both are great and both are useful. I should introduce you to a third way of doing this that I've seen in textbooks and I believe is still used in the Dimensions 6A book, which is where they leave a space here showing that you have 3, you have 24 on top, and you do not know how many of these are going to go in there because it's a broken bar. I think this has been, in my experience, less intuitive to students than this or this. So I would prefer one of these two models. If you're teaching 6A dimensions, you'll see this, but you might show your students this as well. Okay, I think that's all that I have for you. Actually, before we go, there are a few things that I'd like to highlight. Why bar modeling is useful. So let me discuss that for a second. First of all, it's going to give you a model of the problem, and I think it's worth noting that you could take any of my bar models, and once I have completed my bar model, I no longer need the words. So the model can be used by itself. Another point, it's erasable, which is really nice. You can change it as you need to. A third point, you can make adjustments and use the bar model for all it's worth. So you can quickly adjust the problem. For example, on the last problem that we had up here, instead of 24 and 3, you can change the numbers to 2 different numbers. You can say, what if I change the 24? How does that change the problem? So you can quickly adjust the problem. I think it's worth mentioning that you have insight into how a student is reading the problem. Or understanding what the problem is saying. A lot of times students don't make the mistake so much on the math itself, but on the reading portion. So I think it's worth noting that sometimes there might be a reading difficulty as opposed to a math ability issue. I like to say here that one of the big things, or one of the things that I like to say to teachers when I'm training is a picture is worth, and then I let them fill it in, 1,000 words. So if you have a picture, if you have a bar model, you really do have some keen understanding of how they're interpreting the problem. So once you have this, then you know you have insight into errors. Okay, so these are all points that I really like to highlight on why we use bar modeling. So that's all I have for you. Thank you very much.